important things. We started with refraction of light in the session and we understood its definition. You can just go through, and here activity 10.7, 10.8, 10.9 and 10.10 are given. Please go through it. That is about the coin raising, pencil appearing to bend, about all that. You can do it as well. I will also do it and show to you shortly. And next is the refraction through rectangular glass slab, which we studied. One point I forgot to tell you there. What it is andre, when the process of refraction take place in the second interface or second refracting surface CD, children, the emergent ray or the refracted ray will come out now. To that ray of light, incident ray of light, if you extend, first phase into incident ray, if you extend, children, with the dotted line with the help of scale, you see that the emergent ray is parallel to the direction of the incident ray. Both the rays will be parallel to each other. Andre, I will soon draw it here and show you roughly. Iga idana A, B, C, D rectangular slab anta tagondvi. Illond normal draw madidvi. Incident ray idu towards the normal, so refracted ray, incident ray. Aita. Next to incident ray na now illivargu extend madidvi, so that this refracted ray itself is acting as the incident ray for the second refracting surface CD, which is making an angle of incidence I. Since it is travelling from denser to rarer, it will bend away from the normal, making an angle of refraction R. This was the story. Now children, if you just produce this incident ray straight with the help of scale, you can draw it and check. If you just produce this incident ray, you observe that is an emergent ray anta karitare anta heltare. This emergent ray and the incident ray are parallel to each other. How much ever you extend also, it go parallelly, they never meet. Why are they parallel to each other? Another one point I forgot to tell you. When you extend, those two rays, the emergent ray and the incident ray, are parallel to each other. The reason is very simple, children. This incident ray at the first interface and the refracted ray or the emergent ray at the second interface, those two rays direction are equal, but they are opposite in direction. Those two rays are equal, but they are opposite in direction. Adikke enagutte andre higide opposite in direction andre hing hogtade hang hogtade anta alla children. Incident ray hingittu, but refracted ray bending away from the normal andre hig hogta idella. So that is the word, they use the word opposite there. So compared to incident ray, the refracted ray and emergent ray are equal, but they are opposite in direction. Hence it appears parallel. Here in your textbook they are given somewhere. Please, I will tell you, mark it, it is important. Page 83 in your textbook, beside figure 10.10, 1, 2, 3, third paragraph only, you have, children, you may observe that the emergent ray is parallel to the direction of the incident ray. Why does it happen so? The extent of bending of the ray of light at the opposite parallel faces AB and CD of the rectangular face is opposite and parallel. Equal and opposite. That is the extent of bending of right. Illi enagutte idu bandu angle of incidence martade, but compared to angle of incidence and angle of refraction, that is emergent ray, when you compare, children, the extent of bending is equal, but they are in opposite direction. That is the reason they appear parallel to each other. That is one important thing. Next, in the next page, I think you have about the loss of refraction and about the constant of refractive index and absolute refractive index you have. Please go through it. Next is, you please go through table 10.3 given here, which gives the value of absolute refractive index of different media. Now we got very air, water, glass, vacuum anta we studied about the media. In this table, if you refer, children, you have different material medium and those refractive indexes, index values are given in the table beside them. See, like air, ice, water, alcohol, kerosene, fused quartz, turpentine oil alli, benzene alli, ground glass, rock salt ante, various other mediums are there along with this air, glass, water or vacuum. These are the basics which we usually consider, children. Like this, different medium are there and their absolute refractive index value. So other the absolute refractive index value on their, children, it is assumed that one of the medium is fixed, that is air or vacuum anta. Other refractive index ಏನು ಅಂತ they have given. You can check. Refractive index of air is 1.0003, that of ice is 1.31, water is 1.33, alcohol is 1.36, kerosene is 1.44. Like that you can go through the list. You need not memorize this. If problems are asked, the values of refractive index will be given to you. You need not by heart this table, but I wanted to tell you one important point here. That is the reason I am reading here. They have given a paragraph here below the table. Note from table that an optically denser medium may not possess greater mass density. Before the children, more to know anta one box ide illi. Please read in that box, mainly from second line. See, first andana oddtini. The ability of a medium to refract light is also expressed in terms of optical density. So the light is refracting, isn't it? So that is expressed in terms of optical density. Why optics? In the beginning of the lesson itself, I told you about optics. Optics is the branch of physics which is deals with the study of light anta. So optically denser, optically rarer ಅನ್ನೋ word also we use. Denser, rarer ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, optically denser, optically rarer medium ಅಂತಾನು we use the word children. Optics because it is light ಅಂತ ಅಷ್ಟೇ. Optical denser has a definite connotation. It is not the same as mass density. As I said you have already studied. Density is mass by volume anta. So optical density is different from this mass density. Please don't get confused. That is what they are telling here. We have been using the term rarer medium and denser medium in this chapter. It actually means optically rarer medium and optically denser medium respectively. When can we say that a medium is optically denser than other? This is very important, please mark. So how do you compare which is optically denser and which is optically rarer? Denser, rarer, helbidtivi. How? Based on the molecular arrangement I explained you already. How it is optically denser, how it is optically rarer, andre here they have given the explanation, please go through it. In comparing two media, the one with the larger refractive index is optically denser medium than the other. The medium of lower refractive index is optically rarer. The speed of light is higher in rarer medium than denser medium. Thus, a ray of light traveling from a rarer medium to denser medium slows down and bends towards the normal. When it travels from denser to rarer medium, the speed of light will be more and hence it bends away from the normal. So that's it, children. So optically denser, optically rarer. How do you define? Based on the values of refractive index of the medium. If at all, the larger refractive index is optically denser medium. Refractive index ಜಾಸ್ತಿ ಇದ್ರೆ it is said to be optically denser. Refractive index is less means it is said to be optically rarer. Optically denser if refractive index is high. Optically rarer if refractive index is less or low. So now just go through here. ಇಲ್ಲಿ ಏನಿದೆ, refractive index of water is 1.33 children and refractive index of kerosene is 1.44. So refractive index of water, I will write here NW, andre refractive index of water is 1.33, whereas refractive index of kerosene NK is 1.44. No unit for refractive index, no unit I said you. So whose refractive index is more, children? Of course the refractive index of kerosene is more when compared to refractive index of water, isn't it? 1.44 is more than 1.33. Though, but when you compare with this, the mass density is mass by volume, andre water is more denser compared to kerosene. But when you come optically, andre optically denser, optically rarer anta bandaga, children, kerosene is optically denser whereas water is optically rarer medium. So please don't get confused between density, mass density and optical density. Optical density is completely based on the value of refractive index. Mass density andre you know what it is already. So kerosene though density of water is more compared to density of kerosene. But when it comes to optically denser, children, kerosene is optically denser than the water. Why? Because the refractive index of kerosene is more, which is 1.44 compared to the refractive index of water, that is 1.33. So this is about the process of refraction of light. So we have studied what is refraction of light, what are different mediums, about the types of medium, that is rarer and denser medium, how the refraction of light take place in case of two medium, and when the ray of light will bend towards the normal, when it will bend away from the normal anta odidvi. Next we studied the laws of refraction of light, and we studied the concept of refractive index and its formulas, and also about the concept of absolute refractive index and M, that is C by V anta. Next we studied about the concept of optical density, optically denser, optically rarer hege anta. It is based on the refractive index of this medium. So this completes the concept of refraction of light, children. As we studied about the process of reflection of light with respect to spherical mirror, illi we are going to study the process of refraction with respect to spherical lenses. We know already that this process of refraction of light is studied based on for the transparent medium. So we will consider the lens here and not the mirror. Mirror is not transparent. Lens is the transparent medium. As we studied, there are convex and concave mirror. In spherical lenses also there are about concave and convex lens. And mainly here also we shall study about the convex lens, concave lens, about its types, and about the ray diagram, that is the image formation with respect to concave mirror and convex mirror. And here also you have the sign convention with respect to lens. It is same, don't worry. If you have understood the mirror part, spherical mirror hege anta, lens easily you can understand. ಏನು difference illa. Okay na, it is very easy. As you studied mirror formula there, illi lens formula ಇದೆ. Next you have the small concept called the power of a lens. Power of the lens. ನಿಮ್ಮ glass the power ಎಷ್ಟು ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, that is how anta. So this completes the lesson, children. So in the next session, we shall be discussing on this, how the process of refraction will take place through the spherical lenses. Till then, please read the textbook and draw the rectangular glass slab refraction process. Onsati draw ಮಾಡಿ parallel banta you check and go through all the definitions and read the textbook one. Any doubt you can ask with me. Please read the textbook. Don't forget, children. Thank you.